There are many different types of Arduino development boards out there, but they almost all share the same key features. As such, if you can understand the layout of just one Arduino development board, then you can essentially find your way around any Arduino development board you come across. And since this is the case with these boards, I'm going to use the Arduino Uno Revision 3 as our development board of choice to explore the components and features of Arduino development boards. We'll start with the microcontroller. The microcontroller is the brains of the development board. Think of it as a tiny computer complete with CPU, RAM and storage shrunk into a single silicon chip that is then installed onto your development board. The microcontroller handles all the computational work that you task your Arduino development board to perform. It also stores programs that you upload to your development board, and it interacts with devices connected to your Arduino development board. It is the core of the development board, and as I've stated in the previous video, everything else on the board is there to make it easy for us to interact with and connect other devices to the microcontroller. So now let's look at the features that make it easy for us to interact with the microcontroller. We have a USB port. The USB port is usually the main method that we use to communicate with our development board. It provides us a way to upload the programs from our software to the development board, and it is also a means by which we power the development board whilst it's connected to our computers. Once our code has been uploaded to our microcontroller, it may be the case that we may need it to interact with other external devices. This is where input-output pins come into play. Input-output pins are points on the development boards where you can connect different components and devices so that they may be able to interact with the microcontroller on the development board. The DC jack is there to provide us a convenient way to power our Arduino development board when it is being used in a standalone project that may not allow us to connect it to our computer's USB ports. It accepts between 7 and 12 volts. Indicator LEDs give you an idea of what's happening in your microcontroller at any given time. The power on LED tells you whether or not power is reaching your development board. The transmit and receive LEDs show when communication is taking place between your development board and other devices. Then there's the built-in LED. This one is usually used for basic testing and debugging. Finally, we'll look at the reset button. Pressing the reset button restarts the program that's currently being run on your development board. The reset button essentially has the same effect as unplugging and replugging your development board. You can use it in cases where your program execution freezes or misbehaves in some way during debugging. You now know the basic structure of the Arduino Uno development board, and by extension, you should be able to identify the same key elements in any microcontroller-based Arduino development board.